Okay, we're in section 13 now, and this is the zero product rule. Later on, we're going to call this solve by factoring, but right now it's called the zero product rule, which is a fairly simple rule to understand. So we'll cover this. It's going to be a very short lecture, and we'll cover this short lecture. It's very short. And then what we're going to do is we're going to start doing examples. But let's go to the lecture. And what's the lecture going to be on? Zero product rule. All right, so let me do another share with you. And I'm going to go to my whiteboard. And again, hopefully after the lecture, we do the examples that the points that we're driving across in the lecture will be better understood when we start doing examples. All right. So let's take a look. And give me a moment to get my whiteboard running. Okay. So again, zero product rule. All right, blow this up and we're going to go through it. Zero product rule. All right. So it says, it's going to be useful in solving a quadratic or higher degree polynomials. So solving quadratics or higher degree equations. All right. And it's not in the past, the equations that we've had have been linear. All right. They've been linear equations. All right. The forms of they didn't look linear, they turned out that they became linear equation. That means they were degree 1. So they were linear equations, degree 1. Now we're going to be confronted with products. All right, so we're going to be confronted with a product of linear factors. There are many methods for solving these types of equations, many. What I'm going to claim over here, though, is that we want to have an intuitive understanding of what we're looking for. And what we're looking for is what's called a zero product rule. That's what we're looking for. Now, what does it say? It says, if you have a product that equals 0, you could clearly state that the factors in that product are going to be 0. So what do we say over there? Either the A is 0, the B is 0, or they're both 0. All right. The way we write that down is A equals 0 or B equals 0. So let's take a simple example. And over here we have a 0 and we have a product. I want to point out what the product is. It's these two factors here. What are those factors? These two factors over here. So I'm going to tell you, if I see that, I can use the zero product rule. The zero product rule, we have an equation. There is a product, and that product does equal to 0. So what do? I set the factors. Whoops, sorry about that. I set the factors equal to 0. So x minus 1 becomes 0, and x plus 1 becomes 0. Let me point out what I just did over there. I looked at the factors. This is a factor here. This is a factor here. I just set them equal to 0. That's all I've done. Now, generally speaking, they're pretty easy to solve. However, sometimes some people struggle with this, but no, I don't think it's too much of a struggle here. What am I going to say over here? Well, the first equation, x minus 1 equals 0 when x equals 1. That was simple. And the second one becomes 0. That's x plus 1 equals 0 when x equals minus 1. And it really is that simple. All right. So again, you hear me say this over and over again, zero product rule. Here's the trouble with the zero product rule. It depends on your ability to factor it. So factoring is going to be the problem now. You got to get the 0 and then you got to get it factored. All right. So we need a product of linear factors and they need to be equal to 0 for this method to work. All right. So let's take a look at an example. I'm going to pull it on the side for you. So I'm going to take this example here. I'm going to pull it on the side for you. Oops. And so I'm going to go through this one step at a time. So again, I want to point out what we're doing over here. We're doing what's called the zero product rule. What's the first word? 0. I don't have a 0. The way I'm going to accomplish that is by subtracting 3x from both sides, and I'll get a 0. If you do that, what do you get? You get x squared minus 3x, I like to put in standard form, plus 2 is equal to 0. So I have the 0. What I don't have is the product. How do we get the product? By trying to factor it. And I got to be honest with you, it would be awful to give you problems you can't factor. Right now, are there problems you can't factor? Of course there are. and we need some kind of method to do that. So I'm going to say right now, x times x is x squared. That's as plain as day. And the only choice for 2 would be 2 and 1. All right, now I got to come up with signs for it. I'm hoping getting a little bit better with the factoring. It's minus, minus, but no matter what I say, I'm going to check it. What do I mean by that? X times x is x squared. That worked beautifully. Then you get minus 2 minus 1, which is minus 3x. That worked beautifully. And you do get plus 2. Then what do? We set each factor equal to 0. Sorry about that. We set each factor equal to 0. And solve. They're linear. What do you get? X equals 1 or x equals 2. Put a box in that. And I want to talk about checking it. The check is always done with the original. Let's check it out. Let's check 1 first. What would you get? Well, if I square 1, I get 1 plus 2, and 3 times 1 is 3. This worked beautifully. Let's try the 2. What do you get? 2 squared is 4. We're checking this now. 4 plus 2, and 3 times 2 is 6. Also checked beautifully. All right, they generally do. They're generally pretty simple. And again, someone said, I don't want to check those. That's fine. You don't need to check them. Pretty simple problems. All right, let's go back. And I want to point out the work is all down there for you. But what we need to do now is we need to get to the examples. The examples that follow are going to be about the zero product rule. We hope we spent enough time talking about the zero product rule, but now we need to reinforce what we said about it by taking examples. Thank you.